share. Okay, so yeah, this is converting bearing, and we get the bearing decimal degree, and we convert it to azimuth, right? And we used this if statement, right? That was that real nice confusing if statement. So, oops. So I'm gonna go ahead and copy this, and we're going to, what, go to 4.7. So how about we put 4.7 right here. Okay. We'll make it bold and italicized, and we'll paste. Come on. There we go. Maybe I want to move it down one. No, that's good. Okay, and I'll put A to B, B to C, C to D, D back to A. Oops. I don't need this bottom row. Okay, so far so good. And I'll just type in the new numbers, right? So, and all this is going to do for us right now, which is nice because we don't have to go hash this over again, but we have 45.22, and then 47.32, and 14.55. And D back to A was 68 degrees, even. So there are the azimuths. Oops, why didn't that work? Oh, I didn't finish this, huh? Okay. In this, yeah. Let's stretch it out here. I didn't finish this off here. So if it was northeast, I just did that. In this case, if it's northwest, what do you have to do to get, if you have the bearing angle, how do you get the azimuth? $360 minus that, right? Yeah. And otherwise 180 and 180. Okay, so we're good. We're good. So now I fill that down. And it looks like everything's pretty good. Looks like that's what I need. Yeah. Let's change all these to not too many decimal places.
Our last number, I got 112.
For the, okay, is it south 68 degrees west? No, it's not. It's north 68 degrees west. So you're probably right, because I didn't have it right. So northwest is 292, isn't it? Or maybe I got some other ones wrong. Yeah. So northwest, oh, BC is not right either. So BC should be southeast. Okay, do we need to talk about this though? Or should we talk about it? Like how to calculate the azimuth? Okay. So the first test is check for north, right? And then once this pops it, if it's north, it'll use this if statement that I've highlighted. And so it checks for east, so that's northeast. If it's northeast, it's just the bearing angle, right? The azimuth, we're trying to calculate the azimuth. The azimuth is going to be the bearing angle if it's in the northeast quadrant. Because it starts in the northeast quadrant, for crying out loud. And then once it gets past 90, it goes into the southeast, and then you got to figure something out. But also, if it's not east, it must be west, right? The only letters in here are going to be E and W. So if it's not that, it's going to pop past just doing P11, and it's got to be 360 minus that to be in the northwest quadrant. So whatever angle it is off the north, it's actually all the way the other way around. So that's 360 minus the bearing angle. So yeah. And then if it's not north, so that covers it for north and east, northeast and northwest. If it's not north, then it pops it into this if statement, doing the same thing, checking for east and applying the two formulas if it's southeast and southwest, respectively. Well, yeah. See, if you're in the southwest quadrant, like you are with that 68 degrees, no, you're not. Wait. CD is southwest. So let's change that. Oops. CD is southwest. And there you go. And northwest for D back to A. And this is wrong too. This is southeast. I forgot to change all mine. There. Yeah, it's just, okay, I'm not going to show it to you. I'll just tell it to you, right? This is the degrees plus minutes divided by 60. Yeah. Well, and I did put seconds in here just because in case we had a problem where we could just copy that. It's plus seconds divided by 3,600, right? Because there are 3,600 seconds in a full degree. So now I'll show it to you, right? So degrees plus minutes over 60 plus seconds over 3,600. Good? Yep.
The minutes is 20 for north 45.
Thank you. Yep. North 4520. Yes. East. Okay. And then I'll check them all here. BC South 4732 East. Yep.
I got negative for 132.
Okay. So that means you're subtracting when you should be adding, maybe? Which one?
BC.
Okay. So it's southeast, right? So you're going to take the, but it shouldn't be negative ever, right? In the southwest, you're going to add your bearing angle. You're going to add that 14 point, you're going to add that to 180. Because in the southwest quadrant, you're taking your 180 in azimuth plus another, whatever your bearing angle is. In the southeast quadrant, you're going to take this bearing angle, which is 47 degrees, like, okay, and you're going to take 180 and you're going to back up. So you're basically, in the southeast quadrant, it's C. It's BC. Yeah, here's the southeast, right? So if I put the compass rose on there, right? South, east, west. Okay. You went, this is how you figure it. This is your bearing angle, right? This is your bearing, B to C. Azimuth-wise, it's 180 minus that, right? So there's 180 in azimuth. And then it's minus this 47, so that's how we got the same. Isn't it 180 minus 47. Yeah, we were trying to get, I don't know why we did that. But anyway, that is what we get. 132, whatever. Yeah, we were just trying to find the azimuth of BC. So 132. Okay, so the if statement breaks it up into north and south, and then each north and south section is broken up into east and west. Okay, do we need to see the azimuth formula again? I do want you guys to understand it, so I'm totally willing to spend the time on it. I know it's all too easy to just write it down, but here, this one that's highlighted is all south stuff, right? That if statement is purely for south. So if it's east, this section's for southeast, 180 minus the bearing angle, right? And then the other one is if it's not east, or if it's southwest, value if false, right? If it's not east, I'm testing for east. I could have done it the other way. I guess I could have put a W right here and then put 180 plus P11 in this one, and then 180 minus P11 in the next one. Either way, we just separate it and we have 4 possibilities, right? Northeast, northwest, southeast, southwest.
So we don't have to put blank equals parentheses, not like the tick marks and south, or like how you did with north.
Yeah. See, and that's why. Because here's the test, right? For the if statement, it looks at this and says, okay, is that true or false, right? Okay, if it's true, it's going to do this. If it's false, it's going to do this. It's going to go right here.
Okay, so both of those are still under the north.
Yeah.
Right.
And so if it's over here, it's not north, right? So it must be south. So no, I don't have to check for south because I'm already checking for north, and this is where it's not north. So if there was another alternative to north than south, then maybe I'd have to have another if statement to see what's going on with that. But there isn't, so. This is a branching kind of logic technique that's used a lot, so it's confusing, but
Although, what we used, where back to the minutes, did you read that? That was the chunk,
yeah.
and then the mod, right?
Yep. Where did we do that? Oh, right here, right? Where we pulled this number. This is the azimuth, and we pulled it back out to bearing. And so this if statement converted the azimuth to an angle for the bearing angle, right? It's called bearing angle. And then it broke that bearing angle and it figured out by whether, okay, so I can look at this 210. This is problem 4.2, right?
Yeah.
So 210.5 degrees, what quadrant is that in? Well, northeast, southeast, southwest, northwest. So I don't know at first or second. I mean, I kind of do know what you mean, but 210? Where's 180? Southwest. 180 is straight south, right? Any bit more than that, you're getting into southwest, and then northwest, and then south north. So here we are, right? So we look at the if statement for this. Kind of getting off tangent here, but we do another thing here. If oh yeah, that was actually the same one. Decimal degrees. It's close. It in the northeast quadrant it is, right? Here's one. See that? The azimuth and the bearing are the same in the northeast quadrant.
No, I mean the formula for the bearing angle is the same as the azimuth for 47.
No, it looks like it, but what it's testing for is the south and north thing. And the south and north thing tests, it looks at this angle and it does just what we did in our minds just a few seconds ago, right? When I asked you what quadrant's 210 in, well, you think about it and you say, okay, it's more than 180, so it's got to be in the, and it's less than 270, right? So in this case, I'm doing, if it's less than 90 or if it's greater than 270, it must be north. Otherwise, it must be south, right? And so now I've been able to say whether it's north or south. And then here, it's even easier. If it's less than 180, it's east. And otherwise it's west. Once I do that, then I can go to my bearing angle and the bearing angle and look at whether that's north or south. I can figure out, I know what quadrant I'm in because I just figured it out and I use one more statement. Let's see if I can scoot over here. See, maybe I'll go this. Right, if L2 is north, and then I check for east and west. So it's very much the same way, but I'm trying to get the bearing out of it instead of the azimuth. So it's very much the same. It is the same for northeast, but in this case, if I have an azimuth of, it looks the same here too, because I take 360 minus the bearing angle and I'll get the azimuth out of it. Just like if you had the azimuth, I take 360 minus the azimuth and I get the bearing angle.
So the only one different is that the J2 is minus 180.
Yep, yeah, because, and this is why, right? If I'm in the southeast quadrant, it's 180 minus the bearing angle, and that's the same thing, right? And then here, instead of adding 180, right? So if I have like 230, I take 230 minus 180, and that'll be my bearing angle. The other way it was if I had a bearing of 30 degrees, or 50 degrees, yeah, like 230, 210 was it. So if I had a bearing angle of 30 degrees, I would take 180 and I would add that 30 and get the azimuth. So algebraically, it's just if you look at the four formulas, those are all four formulas written right in there. But on paper, VA for bearing angle. In the northeast quadrant, the azimuth is equal to the bearing angle. Down here, the azimuth is equal to, well, 180 minus the bearing angle. Without having to rehash why that is, but if you draw it, you have this angle here, well, 180 minus that angle is your azimuth. Over here, your azimuth is equal to 180 plus your bearing angle. And right here, it's 360 minus your bearing angle. That's your azimuth. Going the other way, algebraically, your bearing angle is equal to your azimuth. That's easy. I mean, algebraically, this is the easiest one. Okay, algebraically, if I switch these, I add VA to both sides and subtract the azimuth from both sides. So bearing angle is equal to 180. So it doesn't look like it's any different, right? But algebraically, that's why. Yeah. And likewise, well, here it does become different because now I don't have a minus in here. So I have to like think of my varying angle. I subtract 180 from both sides. So my varying angle is equal to azimuth minus 180. There's the difference. And then here, same thing. I add BA to both sides, subtract, and so I get, if I get BA by itself, it's just 360 minus the azimuth. So you could memorize all 8 equations if you'd like. I mean, that's not really much of a memorization. But that one if statement can do, well, checks for all 4 quadrants. Using branch if. That's good. No pain, no gain for the brain. Yeah. Good. So, where are we? So here we go. We just converted all our bearings to azimuths, right? For problem 4.7. Now we can use our formula, another formula, to get the interior angle, right? And so what was our formula? The interior angle is the back azimuth minus the, what? The forward azimuth of the next line. So let's start with B, right? So I'm looking at B to C. So maybe I'll put point A, B, C, and D, just so I know what I'm talking about here, right? So I'm gonna start right here because that's where we started on the board. Oh, I'm gonna insert a column here, and I need the back azimuth, right? Remember the formula for back azimuth? Equals something. Well, remember, a back azimuth is just going the other way, right? So if I have an azimuth of 4, say what? Yeah, you either go forward 180 or back 180, depending on where you are in the quadrant, right? So another little if statement, it's not that big of a deal. It's a if statement. It says if the azimuth, right, if that azimuth is greater than 180, I guess, or less than 180, since I accidentally typed less than. If it's less than 180, then I'll add 180, right? So I'll take Q11, whoops, Q11 plus 180. If it's not less than 180, that means it's more than 180, and I'll take 180 minus it. Or I'll take the, if it's greater than, it'll be Q11 minus 180, right? I only needed to test it once, right? Because if it goes past 180, I need to go the other way.
So the azimuth less than 180, that's the test?
Yep.
And then the azimuth plus 180?
If it passes the test, right? If the azimuth is less than 180, it'll do this. Value if true, right?
So if it was greater than, with the minus come first?
Yep.
Okay.
So if I do, well, I still can't type greater. Okay, if it's greater, then I'm going to take a minus. And if it's less than, I'll add. So that'll do the same thing. Good. Sounds like we're kind of getting, it's just repetition. You got to see it a lot to see what's going on. Usually, like if you take a programming class, I don't know if you guys have taken one yet or not, but you'll usually write it in like vertical form where like a math, you know, when you know how you add vertically, it's a lot easier because you can just line stuff up or whatever. And so in in like if you're using Python or something, you would do this. You'd say if, you put parentheses. Actually, you don't even need the parentheses. You just have the test. So my test is Q11, right? So if I had a variable called Q11, right? And I'd say left greater than 180, and then colon. Not that you need to know Python in this class, but and then you indent a little bit, a couple spaces here. I usually do 2 or 3, and then you do what it says, right? So if it's this, what if it's greater? But then I take Q11, and so I would say my varying angle. No, I'm doing azimuth. Oh, my back azimuth, right? So my back azimuth is equal to, if it's greater than 180, I got to subtract 180 from it, right? So it's Q11 minus 180, right? And then I put an else, right? And then I 3 steps in, and then I would say back azimuth is equal to Q11 plus 1.
So you don't need to put a test for else.
Yeah, if it's not that. You can also in the other case where we had an embedded, there's an else if statement where you have more conditions. But this doesn't have any other conditions. It's just that or not, right? Yeah. So those are, I think it's easier to see it this way. In Excel, it's tougher to see, to like look across and hop over what's happening.
Is there a way you can do that?
Not really. It doesn't do it for you. No. It just has to be a single line, and it goes on forever. Or I mean, not forever. Yep. Especially with parentheses and stuff. In programming, you can just use indentions, and that tells Python where if something's inside an if statement or outside of it. So it'll give you an error if you don't do it right. Okay, there you go. I think that'll do it. If it's greater, you subtract. If it's less, then you add, right? So that's it. So see how it's 225? That's the back azimuth. 45 northeast, 45 degrees northeast, right? North 45 degrees east. Back azimuth is southwest, right? So that's 180 plus the 45. So yeah. Okay. So there are all the back azimuths. So now that I have for point B, let's figure out and see if we can get the interior angle, which we figured was the difference between it, between 45 and 132 or something, right? Did we even figure it out? I don't think we did. Did we? Nope. All we did was get the directions. But it is the difference. Oh yeah, we talked about it. We said we got 45 and 132, right? So, well, anyway. So the interior angle, so this whole column is interior angle, right? So IA. My interior angle is, for B anyway, it's going to be equal to, well, the back azimuth of A to B, which would be up here, and then I subtract, it's the difference. Oh yeah, that's where I said it, right here. We didn't do the numbers. I remember subtracting, but it's right here, right? We wrote it down. So it's the back azimuth minus the azimuth, right there. So it's 132 minus the 45, right? So 45 plus that angle should be equal to 132.
So what's that BC? That is, we don't need that thing?
The azimuth of BC,
No.
that's what this is.
Oh, I thought it was like Actually,
Didn't know how to write it. But yeah, so this is
so
the
since those two, the back azimuth and
the back azimuth of the previous line, right? Back azimuth of the previous line plus the azimuth of AP.
okay.
Oh wait. Minus the azimuth of BC. So the one for BC. Back azimuth previous one minus the azimuth of the first one.
Okay.
Now there may be an if statement needed in there because what if I get a negative or something? I'd have to do 360 minus it, but
So for finding the, did we use for the first one, did we use the bottom back azimuth minus the previous?
Yeah. Good thinking, right? So I go all the way down to here, but here's my problem. That looks okay, actually, right? Because I take the back azimuth of the previous one minus the azimuth of this one. But now that I get up to here, okay, again, the previous one, the back azimuth of the previous one minus the azimuth of the one forward. So this has to be equal to the back azimuth of the previous one, this one, minus the azimuth of the one in front of it. Right? Okay, so I do have a negative going on here. So let's think about what's going on. This is from, yeah, I think so. But to be sure, I got to think of the picture in my head, right? So what's going on?
Do we add?
This is at point B, right? So I have this azimuth of 260. Actually, it's this azimuth, right? So I have this azimuth of 292. And I have the back azimuth of 14, right? This is north 14, that's 14 degrees. And I'm backing up, and I get this, I subtract that. Is it really 270 degrees? Negative 270. Yeah, so I'm actually getting the outside angle, aren't I? So 360 minus makes sense. So I need an if statement saying that if I subtract them and it's less than 0, I need to add 360. Because I'm going the other way. So let's do that. I'll add that one to it. So I can start back up at the top. Well, I'll start at B anyway, and I'll put that if statement. If R minus, I think I have to put this in parentheses also. If that is less than 0, then I need to take 360 plus R11 minus Q12. Otherwise, it's just R11 minus Q12. Right? There, that's easier to see, probably. Right, if it's less than 0, then I gotta add 360 to it. Value if true. If not, I just leave it alone, do the deal. So I'll fill that down. And no more negative, right? And then up here, I need to, actually, I'm just gonna fill this up and then change the numbers so I don't have to do the if statement again. Right? So this guy right here is actually the back azimuth of the previous one. Back azimuth. So I'm just clicking, I'm moving the cell locations back to where they should be, and that's it. That was pretty clever, huh?
Less than 0.
Yeah. But you got to put that back azimuth minus the other one in parentheses and check that to be less than 0. And then put a comma. So you might have a parentheses out of place because there's a lot of parentheses going on actually. So that's good.
So for the minutes, was it
Yeah, we just copied it from, do you have that one?
no.
Oh yeah, you were here, sorry. So copied and pasted it, but yeah, for the minutes, we did, instead of a truncate, we did a modulus, and that took the 0.6667 one,
Okay.
and then we multiplied that by 60, and then rounded that to 6 decimal places, so it would take it. Normally you truncate it, but if it got real close to like this repeating decimal, like 20 minutes is actually a third of a degree, right? Third of an hour, 20 minutes, third of an hour. So it's third of a degree. And that's 0.33333333 forever, right? And so the other way is 0.6666666666 forever. And so if you truncate that, you're gonna get like, in this case, 39 degrees, 0.999999999, right? And so if you truncate it, you're gonna get 39 instead of 40. So if you round it, you get your 40 instead of your 39. And that's what we were given. So you get 40. So if I use a trunk here, a trunk, see, I get 40. Yeah, why would I do that? Oh yeah, that actually does work with this, but if you had some other number, sometimes it doesn't, so we use round. Yeah, my minutes, I changed it to round, but if you leave it at trunk, it's gonna work okay. So that's a slight variation in the formula. I did.
Okay, so for the seconds, would that be the same formula but with 3600?
No.
Or different?
For seconds, you get basically what you need are decimal minutes, right? So you take the modulus of your angle, so that's the 0.66666667, right? And you take the modulus of it, so you get that, well, you take the modulus of this number, so you get 0.6667. And then you multiply that by 60, and that's your decimal minutes. Okay? And then you take the modulus of that to get the remainder for your seconds.
So you don't take the mod from the interior angle, you take it to the minutes, right?
Well, basically, but yeah, here it is, right? So I take the modulus of the original interior angle, T, the interior angle, divided by 1, and I multiply it by 60. And then I round it to 6 decimal places. Actually, I shouldn't round it. That's okay. That'll work too. And then I take the modulus of it and multiply it by 60. So there's the multiplied by 60 again. So interior to this is you're actually multiplying it by 3600, but you're taking, before you can multiply by that second 60, you got to take out or round out. You got to take out the whole number part, not round it out. I don't think I have to round in the seconds, actually. I could just truncate it. In fact, you kind of should. Actually, no, that works okay. Yeah, rounding works better, actually, than truncating. You can truncate the degrees, but after that, the rounding is better.
So from round all the way up to the 6, that's minutes, right?
Yep. And then if I take the modulus of it, that's the remainder of it, right? So all this right here is decimal minutes.
Okay.
So I take the modulus of it to get me the remainder of it, and I multiply that by 60 to get seconds. And we've done this before, but I think it's worth showing. On a calculator, if I had 66.666666, right? So 66.6, as far as it goes, right? And I want to break this up into degrees, minutes, and seconds, right? I write down 66, and then I take the modulus of it. So in this case, I could just subtract 66. And there's 0.6666. There's my 20 minutes, isn't it? 20 minutes is 0.6666. It's 1/3, or it's 2/3. Actually, this is 40 minutes because I subtracted from the, anyway. So there it is. And so I need to multiply that by 60, and I get 39.9999, right? But if I truncate that, I'm going to write down 39 instead of 40, right? And that's where the problem is. But I know that if I round it to like 6 decimal places, then I'm going to get a 40 in no seconds instead of 39 in 60 seconds, which is kind of the same thing, but it's uglier. That's all.